Good day, everybody. Welcome to the class today, and this is Easy Learn with Samuel. Today, we'll be looking into refraction of light through rectangular block. Refraction of light through rectangular block. Now, with what you have on the board, you can see that I already have my rectangular block drawn. Okay. Now, this is actually being done by sort of practical. In fact, it's practical. This question always comes with practical, but I will explain anyway. Now, what you do is that you place your rectangular block on a plain paper, like a drawing board, and you draw out the shape, okay? The shape of the block. You use a pencil to draw the shape of the block, which you are going to have something of this nature here. Now, after that, you name it A, B, C, D. So this is our side AB and our side CD, okay? Now, after that, you draw your normal. The question normally will be given an angle of incidence which you're expected to mark out with your protractor over here, somewhere around here. Now let's assume that you've been given your angle of incidence and you've marked it out. The next thing you will do is that you will draw your line of incidence to show the angle of incidence. I think you understand what I'm saying. Now this will be your incidence ray. Okay. And over here will be your angle of incidence. Okay, that will be an angle of incidence. We can now say, let's call this high. And let's call, okay, so let's say that is our point O. Okay, that's our point O. Now, the next thing is this. When you're being given the question expects you to place two pins on your incidence ray. One will be at this point, other one will be at the point here. So you'll be given two pins, one here, one here. Let's call those pins P1 and P2. Let's say P1 and P2. P1 and P2. Let me draw a small shape. Okay. Let's change the color of our pen to represent our. Let's say P1 is here, now P2 is here. I'm going to adjust this anyway, don't worry. Okay, those are the 2 points, point 1 and point 2, or you can say pin 1 and pin 2, pin 1 and pin 2. Now, when you are done doing this, you will replace your rectangular block. You will replace your rectangular block on the shape you have drawn. You make sure that it is exactly on the shape you marked out with your pencil. Now, after that, you will come to this side, to side CD. You come to side CD, and you will try and look at your 2 pins right from within the block. Okay, this is side AB. So you come down to side CD to look for your pins. Actually, you will actually see those pins, but you will make sure that you look at them in such a way that pin 1 and pin 2 will be on a straight line, such that you will not be able to see the second pin. You'll be seeing one pin, but the second pin will be in line with the first pin, which means that it will be covering the second pin. That shows that they are in line. You know, when you have 2 or 3 or 4, 5, 6 people on a straight line, okay, and you are standing, you know, vertically looking at them, you can only see the first person. You'll be able to see others because they are in line. Do you understand? In a very straight line. So that is exactly what we make sure you see. You make sure that you look at it in such an angle that the pin 1 and the pin 2 are being seen on a straight line. Now, when you get that, you will now attach your third pin. Okay, you attach your you fix your third pin. Let's say you fix your third pin at a point here. Okay, P3. When you are fixing your third pin, you make sure that that third pin is what is in line with the first two pins, making it difficult for you. In fact, impossible for you to see the second and the first two pins. When you are applying this third pin, you make sure that they are all in line. Okay, you make sure that they are all in line, so that when you're looking at this third pin, you'll not be seeing your second pin and you'll not be seeing your first pin. You will not be seeing your second pin and you'll not be seeing your third pin. Right when you're looking from right from here, you'll be looking from. Let me quickly draw something here. Okay. Let's say this is you here. Let's say that this is you. This is you here. Okay, so when you're looking at this third pin that you have fixed, you must not be able to see your what? Your second and your third, your second and your fourth pin. You only see this third pin. If that is done, then you will apply another pin, the fourth pin. You'll be given 4 pins anyway. So you make sure that you place your fourth pin. Now, when you place the fourth pin, this fourth pin must be blocking your third pin. Must be blocking your third pin, at the same time your second pin and the fourth pin, making sure that all the three, when you're looking at it from here, you'll be seeing only this pin, whereas this third, second, and fourth pin are all on a straight line with it. So you won't be able to see the second, the third, the second, and the third pin. Now, once that is done, you will draw a line. A line will be drawn. A line will be drawn. Sorry. To match these 2 points, these points. Okay, you draw a straight line to match the points. Yes. You're supposed to have something like this. Don't mind my points. You can see that they're not on a straight line. That's because I'm not actually having the practical done. Just explain to you. So now, this will be your P3, that is pin 3, and pin 4. Okay, pin 3 and pin 4. Then what we do, you have your number here again. You have your number. Okay, you have your number. Now, when that is done, we call this angle of emergence, E. That is your angle of emergence. We call it E. Let me just write it somewhere here. Then I'll move it there. Let's call it angle E. Probably let me just print this as it is. Okay. Okay, P3 and P4, let me make it smaller. Then, so this will be able to. Okay, good. Okay, so now that's your angle of emergence. Now the next thing you do is that you are going to draw a line to match this point this point where the light ray entered the glass, and this point where the light ray emerged from the glass back into the air. You know, there's a point here. This is where the light ray emerged back into the air from the what? From the glass, and this is the point where the light ray entered the glass from the air. So what to do is that you now draw a straight line to join the two, like this. Now let's get that done. Let's draw the straight line. Don't worry, it will be adjusted. Okay, I think this is good. Now, good, yes, very good. Looking at this line that we just drew will now serve as your what? As your refracted ray. Remember, when light ray enter from a less dense medium into a denser medium, there will be a refraction. Then after that, there will now be an emergence ray. Now, this is your what? This is your angle of refraction. That is your angle of refraction. That is your angle of refraction. But all the same, we are not yet done. We are not yet done. Look at this line, this incidence ray. Let me prolong it. I will try and get that adjusted anyway. Sorry for the technical glitch, please. Okay. Good. Okay. Now let us look at this. Our what? Our extended incidence ray. Sorry. The angle here, this angle, we call it angle of derivation. Let me call it D. Angle of derivation. We call it angle of derivation. We call it angle of derivation. Now, looking at this critically, looking at this, if this line should come direct like this, okay, then you will believe with me that your angle of incidence will be equal to the summation of your refraction, of your angle of refraction and your angle of derivation, which means we have this relationship between them, that is your I equals to your R plus D, which means for you to get your D, it will be equals to I minus R. That is your angle of incidence minus your angle of refraction. And that is the relationship that you have over there. Sorry. Okay. Now, there's something I would like to tell you. Note. Note. Your angle of emergence, okay, your emergence angle is parallel to your angle of incidence. Theoretically and practically, yes. Okay, so Whatever your angle of incidence is, that is exactly what your angle of emergence will be. Okay? Note, your angle of incidence is always equal to your angle of emergence. Now, I will quickly try to explain this, and I want you to be very careful. This is like a little proving, which I want you to understand and grab. Okay? Now, this is it. When your light ray is entering from air into glass, you have our refractive index to be that of glass to be equals to sine high over sine high. Are you getting this? Sine high over sine high. Now, but you know something, that when your light ray is now moving from glass back into air, when the light ray is moving back from glass back into air, we have it to be this. It will now be refractive index of air with respect to glass to be equal to, now it's going to be about sine high over sine high. In this case of our sine high, the refraction is serving as the what? As the sine high, because this angle here, this angle of refraction here, will be the angle of incidence here. I think you understand what I'm talking about. The angle of refraction, this angle here is equal to this angle here. I'm sure you know that mathematically. So which means your angle of refraction here is serving as angle of incidence here. Now, let's continue. Remember that, let me quickly do this so that we can be able to, sorry. Okay. Remember that we have this to be in your, I think in the first class I did for you on this topic, I said this is equal to this. If you can remember. Now looking at this, I cannot substitute the value. Let me now bring this value and this value into this and this. Instead of writing refractive index of glass with respect to air, I will write this. And instead of writing refractive index of air with respect to glass, I will write this. So let's go. That will be sine high over sine high equal to what? Equal to 1 over sine high, sorry, 1 over sine high all over sine high. And from our mathematics, we know that our sine high equals to sine high will definitely be equal to what? Because this is 1 over. That means 1 over 1 times what? Sine high over sine high. Okay. Okay, let me quickly do this again. So from here, we can easily say that we have this. We have okay. So we can say we have sine high over sine high to be equal to what? Sine high over sine high. And this is just to show that our high is equal to our E. Okay, that's just it. I just wanted to know that when you're having refraction in your what? In your through your rectangular glass, what happens is that your angle of incidence is equal to your angle of emergence. Your angle of incidence is equal to your angle of emergence. Now that's what about that. Now let's solve the question. There are so many ways to prove this anyway, okay, but I don't want to take our time. So let's just quickly solve the question. But you note that your angle of incidence is equal to your angle of emergence, and your angle of deviation equal to your what? Your angle of incidence minus your angle of refraction. Okay, so that's that about that. And also, some questions they may ask you that what is the angle between your incident ray and your emergent ray? Look at this. If I draw this line like this, what do you notice? You will notice that both lines will be what? They will be parallel. If you have done your practical well, you can see it will come straight and it will go like that. So normally they are supposed to be parallel and they are not supposed to meet at all. Okay, but you know I didn't do the practical. I just used my hand to do this. So if you do your practical very well, this incident ray and your emergent ray will be what? They will be parallel. And so when they are parallel, there won't be any angle between them. So if you say a question like that, that's asking for the angle. I think we have one here anyway, but I'll just read it out to you. The angle between them will be what? Will be 0. So let's quickly go to the first example. Okay, let's read the question aloud. A ray of light incidents at an angle of 30 degrees at an air glass interface. 1. Draw a ray diagram to show the ray in the glass. 2. Determine the angle of deviation. Okay, determine the angle of deviation to stop. Refractive index of the glass is what? 1.50. Let's solve. Let's swing into action straight. Now the question is that what? First of all, determine. Okay, draw a ray diagram to show the ray in glass. Now let's start. We want to draw a ray diagram. Before that, we have to get our glass drawn. Okay, this is our glass. And the question says that a ray of light incident at an angle of 30 degrees at an air glass interface. Look at this, air glass interface. Always note that they are telling you that it is an air to glass interface, which means the air is moving from the light ray, is moving from the air into the glass. And you know our air is less dense while our glass is denser. So you're going to have incident ray and the refracted ray. Okay, so you're going to have something of that nature. Let's quickly do that. The first thing to be done, let's get our normal drawn. I want to have my normal here. Then my incident ray. Let me draw my incident ray. You know, you're just sketching. You're not actually measuring the angle. It's to be measured. It will definitely be okay. Solution. Okay. So let me open this and this like this. Okay. Now the question says that what? Okay, we are still moving on. Let's get our. Let me first draw my derivation. I think this is straight enough. For derivation. Okay. Or I can decide to make it. Take it like this. Okay. Now the next thing is what? Is our what? Then we need to draw the refracted ray. The refracted ray. Let's come this way. You know, we always we have our refraction in this manner. Okay, let me delete this. Let me use red to show refraction. To show that it's a refracted ray. Okay, so okay, this is our angle of incidence. This is our angle of our elevated angle deviation, and this is our angle of refraction. Now let's solve the question. You know, our normal. Okay, let's not forget that. Normal. Okay, so according to the question, this is air and this is glass. Sorry, glass. Now we've done number one. The first one is done. They said we should we're supposed to draw a ray diagram to show the ray in the glass. So we have done that. Okay. Now the second question says that determine the angle. Oh, sorry, something is wrong with that question over there. I think the other time. Determine the angle of deviation. Yes. Determine the angle of deviation. That's what we have been asked to calculate. Determine the angle of deviation. Something is wrong with. I think the other time when we had issue with this. Okay, you can see determine the angle of deviation. Determine the angle of deviation. Now you can see there, determine the angle of deviation. Now, let's start question two, number two. Given, like I always do, given, what are the parameters given? Height, our height equals to, what's the angle of incidence? 30 degrees. What's our angle of refraction? Unknown. What's our angle of deviation? Unknown. But we have our refractive index with the word 1.50. Now we are being asked to find our angle of deviation. Remember, from what we did here, we said our D equals to what? Angle of incidence minus angle of refraction. But fortunately, we don't know our angle of refraction. Our refracted angle, we don't know it. We only have our incidence, angle of incidence. So the first thing I'm supposed to do is to what? Find our refracted angle. So let's go and find the refracted angle. First, to do that, remember we had this formula. Refractive index equals to sine I all over sine r, which means 1.5 will be equals to sine what? Sine 30 all over sine r. Okay. You can solve this further. Okay, you know what we're looking for is our R. So I can say our sine r will be equal to sine 30 all over 1.5. Sine r. Sorry for technical glitch. Sine r definitely equals 0.5 over 1.5. Okay, let me quickly do this. Okay. Good. So, and our 0.5 divided by 1.5 gives you what? 0.3333. So our sine r equals to 0.333, and it continues by that. So I can just say my r will be equal to sine inverse of 0.333. I'm sure you definitely know what I've done there. So when you put your sine inverse of this number, you are going to have 19.47. 19.47 degrees. 19.47 degrees. Let's do the, okay. Oh, sorry. 19.47 degrees. And remember that our D equals to I minus R, and that will be equals to what? 30 minus 19.47 degrees. And that will going to give you 10.52. I think we have 10.53. Okay, let's just about 10.5 degrees. 10.5 degrees. So that's going to be our angle of deviation. Very simple. Very simple. And the question I was talking about the other time about when you have been given a question about the angle between the incidence rate and the refracted rate. Let me just read it out to you. Listen carefully. You can go back to listen to the question again if you can't get it. A ray of light is inclined at angle of 30 degrees on one top surface of a parallel-sided glass of refractive index 1.5. The ray finally emerges from the low surface. Okay, what I'm just telling you is that a ray is what is incident on this type of side, and finally it emerges on a low surface here. Okay, and the refractive index is what 1.5. They said the ray finally emerges from the low surface. What is the angular deviation of the emerged ray 60 degrees? Of the emerged ray, option A 60 degrees, option B 39 degrees, option C 20 degrees, and option D 0 degree. Option D 0 degree. Now, let me use what you have here to explain what this question for you. Let me just use this diagram. Now let's assume that this is what they are talking about. Okay, this is your incident ray, this is your refracted ray, and let's say you now have an emergent ray over here. Let's say you have an emergent ray. Okay, before that, let's say you have, let me first of all elongate this. Okay, let me elongate this here. Okay, let's assume that you now have an emergent ray of this. Remember that I did not conduct practical on this, I'm just using this as an example. So now, let's assume that this is what you have. This angle of deviation is only between your what? Your incidence, your incident ray and your refracted ray. Let's assume that this is now elongated. Let me produce this. Let me produce this upward like this. Let it be produced like that. See, okay. And let this also be produced. Looking at what we have here, looking at that, do you think your incident ray, which is this, and your refracted ray are going to meet at any point? You can continue elongating it. You can produce it downward like this, produce this to downward, and produce it upward. If this particle is done perfectly, these two rays, your incident ray and your emergent ray, will not meet. Okay, which means you are not going to have any angle of deviation between them. Do you understand it? So, angular deviation between the incident ray and the emergent ray is technically 0. It is technically 0. This particular question I read out to you is Jam 1987, so you can go and go through it if you have your something with you. So let's talk about that. I want to stop here for today on this topic. Okay, you can solve so many other questions, and if you have any question you can't solve, I told you, get through to me. I will do that for you. But don't forget to subscribe to the channel. Okay, this is free for you, so just subscribe to the channel. And we'll meet next class. Thank you very much. God bless.